friends, in this video I tell you about the Cayley Hamilton theorem. So first of all you must know the statement of this theorem. According to the Cayley Hamilton theorem, every square matrix satisfies its own characteristic equation. Every square matrix satisfies its own characteristic equation. For example, let A be a square matrix, and if lambda cube minus 2 lambda square plus 3 lambda minus 4 equals to 0 be its characteristic equation, then according to this theorem, this equation must be satisfied by a given matrix. Means A cube minus 2A square plus 3A minus 4I must be 0. Now using this theorem, we can easily find out the inverse of the matrix A. For a given matrix A, we can easily find out the inverse using the Cayley Hamilton theorem. So, on pre-multiplying above equation by A inverse, if we multiply this equation by A inverse, we will find out A inverse A square minus 2A plus 3I minus 4A inverse equals to 0, or A inverse is equals to 1 by 4 A square minus 2A plus 3. So this is quite simple method to find out the inverse of a given matrix using Cayley Hamilton theorem. Now let us consider this example to verify Cayley Hamilton theorem and also to find the inverse of this matrix. So the characteristic equation of matrix A is given by A minus lambda I, determinant of this, equals to 0. So first of all we will find the value of A minus lambda I. So this is 1, 2, 2 minus 1 minus lambda, and I is the unit matrix or identity matrix. So this is 1 minus lambda, 2 minus 1 minus lambda. Now A minus lambda I, determinant of this, is equals to 1 minus lambda, 2 minus 1 minus lambda equals to 0. So we will simplify this determinant first. So 1 minus lambda minus 1 minus lambda minus 4 is equals to 0. Now simplify this equation. So this is minus 1 minus lambda plus lambda square minus 4 is equals to 0. That is lambda square minus 5 is equals to 0. So this is the characteristic equation of the given matrix A. According to Cayley Hamilton theorem, this characteristic equation satisfied by the matrix A. So A square minus 5I equals to 0. Lambda square minus 5 equals to 0. This is satisfied by the matrix A, that is A square minus 5I equals to 0. So we will prove this equation. So A square equals to 1, 2, 2 minus 1, 1, 2, 2 minus 1. So multiply these matrix. This is 1 plus 4, 2 minus 2, 2 minus 2, then 4 plus 1. How much it is? This is 5, 0, 0, 5. Now, A square minus 5I equals to, what is A square? 5, 0, 0, 5 minus 5I means 5, 0, 0, 5. So this equals to 0. Hence, Cayley Hamilton theorem is satisfied for the given matrix A. Now, we will find the inverse of this matrix. See, we have already calculated the characteristic equation of this matrix, that is lambda square minus 5 equals to 0. and this equation is satisfied by the matrix A, that is A square minus 5y equals to 0. Now, using this equation, we can easily find out the inverse of the given matrix. So, multiply this equation by A inverse, means A inverse A square minus 5y equals to 0, or A minus 5 A inverse is equals to 0, or A inverse is equals to 1 upon 5 A, means inverse of the matrix A equals to 1 by 5, 1, 2, minus 1. So this is the inverse of the given matrix.